Welcome to Dalton's atomic theory. In the last video, we introduced John Dalton and his law of multiple proportions, and we said that we finally have some evidence for the existence of atoms. So Dalton comes along, and he's the first one to really comes up with some substantial theory for atoms other than, I think atoms exist, that Democritus proposed. So in 1808, John Dalton presents his theory of atoms, his atomic model. So each element is made up of tiny particles called atoms, and he says that the atoms of any given element are identical. The atoms of different elements are different in some fundamental way. He didn't know what it was, but he was saying, well, they're different in some way. And also chemical compounds are formed when atoms of different elements combine together with each other. And a given compound always has the same relative numbers and types of atoms. So something like water always has the same ratio of hydrogen to oxygen atoms. And chemical reactions involve reorganization of the atoms, which means changes in the way that they're bound together, but not changes in the atoms themselves. Right? The atoms themselves are not changed in the chemical reaction, at least as far as Dalton says. So Dalton goes on and he does some experiments with water. He finds that water contains 8 grams of oxygen for every 1 gram of hydrogen, which means that if the formula for water was OH, with 1 oxygen and 1 hydrogen, then oxygen has a mass that's 8 times the mass of hydrogen. Now, if the formula for water has was H2O with 2 hydrogens for every 1 oxygen, well, then oxygen has a mass of 16 times the mass of hydrogen. Now, Dalton here makes an assumption. He makes an assumption that nature would be as simple as possible. And so what he's saying is that he's assuming that water has a formula of OH, not H2O. So, if water has a formula of OH, that means that hydrogen has a mass of 1, and oxygen has a mass of 8. Now, of course, we know that he's not right. He's wrong there. Water has a formula of H2O, which means that this statement is true. That means that oxygen has a mass of 16 times the mass of hydrogen, which is in fact what we see. If you look at the periodic table, hydrogen has a mass of approximately 1 atomic mass unit, and oxygen has a mass of roughly 16 AMU. So, it's close, but his assumption was wrong. His assumption that nature would be as simple as possible was not totally true, at least. So, by doing this sort of thing, comparing different compounds and finding the mass, the relative masses of each element, and then comparing all these ratios together, he's able to come up with the first table of atomic masses, which then, of course, leads to the periodic table as we have it formulated today. So, now, many of his masses were later found to be wrong, like his mass of oxygen he labeled as 8, but that's largely because he's making this assumption that the formulas are as simple as possible. He's assuming that 1 oxygen is being bound to 1 hydrogen in water. But when we fix that assumption, when we change that, and we find out how many hydrogens and how many oxygens are involved, you know, he's doing pretty well. So, how close was Dalton to what we currently think is true for an atomic theory? Well, he said that each element is made up of tiny particles called atoms. That we think is true. Now, he said that they were indivisible. Now we know that that's not true. We know that we can split an atom apart and get out protons, neutrons, and electrons, and furthermore we can split protons and neutrons to get out quarks, but this part of it is true. The fact that they're indivisible is not true, but that bit of it is true. Each element is in fact made up of tiny particles called atoms. Now, he also said the atoms of a given element are identical, and the atoms of different elements are different in some fundamental way. The atoms of different elements are different in some fundamental way. They have different numbers of protons in it. But he said here, the atoms of a given element are identical. That's partly true and partly false. It's true in the sense that atoms of a given element have the same number of protons. But atoms of any given element can have different numbers of neutrons. which means that they're not identical, but they are very similar. And changing the number of neutrons in the nucleus of an atom doesn't change much the way it reacts chemically. And so we call them the same element. There are some very small differences in how they react, but they're not very large. So, then he said chemical compounds are formed when atoms of different elements combine with each other. That's true. And a given compound always has the same relative numbers and types of atoms. That's true. Water, H2O, always is 2 hydrogens, 1 oxygen. So that's true. So chemical reactions involve reorganization of the atoms, changes in the way that the atoms are bound together. Well, that's true. We know that chemical reactions don't change the atoms themselves. We're just rearranging atoms in the way that they're bound together. So Dalton is pretty darn close here. Right? And this was over 200 years ago. So, another chemist, Joseph Gay-Lussac, comes along and he finds that 2 volumes of gaseous hydrogen react with 1 volume of gaseous oxygen to form 2 volumes of gaseous water. Furthermore, he finds that 1 volume of hydrogen reacts with 1 volume of chlorine to form 2 volumes of hydrogen chloride. So, combining that, then Amadeo Avogadro proposes that at the same temperature and pressure, equal volumes of different gases contain the same number of particles. So, if we keep the temperature and pressure the same, Avogadro is saying, well, 1 liter of this gas has the same number of particles as 1 liter of that gas. So if we go back and we look at what Gay-Lussac was looking at, he says 2 volumes of gaseous hydrogen react with 1 volume of gaseous oxygen. So if the volumes of hydrogen and oxygen contain the same number of particles per volume, that means that we have twice as much hydrogen as we have oxygen by number of particles. And so now we have a way of saying, well, now we know that there are twice as many hydrogens as there are oxygens in water. So now there are 2 hydrogen atoms and 1 oxygen atom in water. Whereas here, when we make hydrogen chloride, we have 1 volume of hydrogen and 1 volume of chlorine. So even though the mass of hydrogen is so vastly low compared to the mass of chlorine, chlorine has a mass of approximately 35. So, even though the masses are so very different, we're saying that we have a ratio of 1 to 1 by atoms in hydrogen chloride. And now we know that that's true. So, we have some more evidence for the existence of atoms and molecules in some case. So, Avogadro is saying that, at the same temperature and pressure, equal volumes contain the same number of particles, same number of molecules, or the same number of atoms. So, this is Dalton's atomic theory and some evidence in support of it.